Okay, so now I'd like to go through some sample problems on hypothesis testing. Okay, I think this will help you do the homework a lot. So remember, we said there were 5 steps. I'm going to actually kind of modify that, amend that a little bit. I'm going to add a 0th step before we state the 2 hypotheses. So I'm going to say that there's 6 steps for performing a hypothesis test. The one that's new is we want to organize the given information. Then we're going to state our hypotheses, calculate test statistic, compute the p-value, make a decision on one of those 2 hypotheses, and state the real-world conclusion. Okay, let's see how this works. So we're going to start off, we're going to say that an inventor has developed a new energy-efficient lawnmower engine. He claims the engine will run continuously for 5 hours with 300 minutes on a single gallon of regular gasoline. He has a stock of 2,000 engines and he selects a simple random sample of 50 to test. And the average running time of those 50 machines is 295 with a standard deviation of 20 minutes. And we want to test a null hypothesis that the mean run time is 300 minutes against the alternative that it's not. And our alpha is going to be 0.05. So here's what we're going to do first. We're going to write down some of the given information. We have to know alpha, that's 0.05. We have to know the hypothesized value. What is the value that he's putting a belief in? Well, it's 300 minutes, right? The sample mean, the estimator from you, is 295. We have 50 engines in our sample, so sample size. We're assuming that the run times are normally distributed. Okay, so the distribution for X is normal. And we don't know our population standard deviation. Notice this standard deviation comes from the sample. Okay, we ran the engines and the standard deviation from that sample was 20. Okay, so let's state our hypotheses. Well, we can see the null hypothesis is that mu is equal to 300. And of course, the alternative, and this should be H1, I don't know why I keep doing that, H sub 1, this is going to be mu is not equal to mu naught, or in our case, mu is not equal to 300. There we go. Whoops. And there we are. Okay. All right. So we stated our hypothesis. We organized the data. What do we have to do next? All right. Well, we got to compute the test statistic. So here's what we have to understand. We have to figure out what, first of all, the test statistic is always x bar minus the hypothesized mean divided by the standard error of x bar, which is a standard deviation over the square root of n. But notice we have to figure out if this is the sample or the population. And here it's the sample, so this is going to come from a t-distribution. Okay, so we compute our test statistic t sub 0, and we get minus 1.77. Okay, now we compute the p-value. So here we have to use an Excel program. We know that the distribution of t naught is a t-distribution with 49 degrees of freedom. Okay, our value is minus 1.77, so we do a two-tailed test. This is minus 1.77, this is positive 1.77. So I'm going to use a program to find out the CDF for minus 1.77 for a t-distribution with 49 degrees of freedom, and I'm going to multiply that by 2. And when you do, p will be 0.08. And I did this in an Excel file, okay, that I can show you. Let me see if I can find the Excel file quickly. Here it is. Yeah. Okay, so here we go, and notice that this is, I have the number of tails 2 times, and this gives me the CDF for the t-distribution, where this is our test statistic value, that's an I3, and this is our degrees of freedom. And we find that's basically 0.08. Okay? Alright, well now we're pretty much done, because all we have to do now is we need to use our decision rule. So our decision rule, we find out that p is greater than alpha, so we fail to reject the null hypothesis. So let's state our real-world conclusion. What did we conclude? We decided not to reject the null hypothesis, What was the null hypothesis? The null hypothesis was that the mean was equal to 300. Let me put mu in here. Okay, so here's how we make our statement. We say at a significance level of 0.05, we find there is not enough evidence to conclude that the average running time of the lawnmowers on 1 gallon of gas is not 300 hours. Okay, that's how we state our conclusion. There's not sufficient evidence to conclude that H naught is not true. Okay, let's look at the second problem. So here we have a group of college kids. So we know that in the general population of Americans who drink coffee, they generally drink 3 cups a day, and a university wants to know if the students tend to drink more than the national average. So this is going to be the alternative. This is what we're trying to prove. Okay, this is the status quo, and we want to prove this. This is the research hypothesis, the alternative. Okay, they ask 100 students how many cups of coffee they drink each day and found that the average is 3.5. And we're going to assume that we know the population standard deviation is 1.5. Okay. Then we're going to say, okay, do we have evidence to prove? And hold on a second. I think I need to change. No, that's okay. For some reason that looked wrong for a second, sorry. Okay, right, so this is going to be 1.5. We want to say, do we have evidence that the students drink more than the national average? Okay, this is what we're trying to prove. So first we organize our data. Our significance level is 0.01. The hypothesized mean is 3. We have 3.4 for x bar, a sample size of 100. The distribution is not given, but n is greater than 100, so we're okay. We can use the central limit theorem. And we do know the population standard deviation. So we state our hypotheses. The null hypothesis is that it's 3 or less. The alternative is that it's greater than. And again, let me change this. Okay. Notice that this time we were able to figure out the alternative. Sometimes the alternative is easier to figure out because the alternative is what you're trying to prove. It's like when you're in a court, right? What you're trying to prove is the alternative, right? Okay, so now let's go ahead and we're going to compute our test statistics. So the key thing to know is that because n is greater than 30 and sigma is known, our test statistic is going to come from a normal distribution. We go ahead and compute it. We get 2.67. Now we need to compute the p-value. Okay, so we know that the test statistic comes from a standard normal. Its value is 2.67. We're doing an upper tail test. So again, we can use Excel. If we put in all of this information, we're going to find out that the test statistic is 2.677 and the probability is 0.00383. Okay? And actually I need to change this. I was right. The standard deviation should be 0.15. Sorry about that. I knew it did not look right. This should be 0.15. There we go. Okay. And I need to change this up here. I knew that did not look right. Okay. But in any case, the test statistic comes out the same. I just need to change this down here also, just to be careful. Okay. And we're going to get 2.67. Okay, that's going to be what that difference is. Okay. So we go ahead now and we compute the p-value, which is what we've done here. We found it's 0.004. Okay, we put 0.15 in. Put all the other information in. It's a very small p-value, so we automatically know that p is going to be less than alpha. So we're going to reject H naught. Okay. So what did we decide? We're going to state our conclusion. We rejected H naught. H naught was the hypothesis that it was going to be less than 3 cups. Okay. And so now we're going to say at a significance level of 0.01, we find there is sufficient evidence to conclude that the average number of cups of coffee drank by college students daily was greater than the national average of 3 cups. Okay, so hopefully this gives you a little bit of insight into how to do hypothesis testing, and now you can go ahead and you can do those homework problems.